Pyramid building technology. How did they do it? Cutting, transporting, and fitting tens of tons of stone precisely to the millimeter without modern machinery? Using bronze tools, ropes, or lost technology? The pyramids of Egypt, and particularly the Great Pyramid of Giza, have long stood as enduring mysteries, testaments to the ingenuity, vision, and sheer determination of the ancient world. For centuries, standing in the shadow of these monumental structures, observers have asked the same questions. How did people thousands of years ago, with what seems to be only rudimentary tools, construct such colossal buildings? How did they cut, move, and assemble stones weighing tens of tons, fitting each block so precisely that a blade of grass can barely slip between them, achieving an accuracy that would challenge even modern builders? Was it simply a matter of clever engineering with bronze tools and ropes? Or did the Egyptians possess some lost technology now forgotten with the passage of time? To begin unraveling this mystery, we must first understand the context in which these pyramids were built. The Great Pyramid at Giza, commissioned by Pharaoh Khufu around 2560 BCE, is composed of approximately 2.3 million limestone and granite blocks, some weighing as much as 80 tons. The entire structure rises 146 meters, about 481 feet, into the sky, its base stretching over 13 acres. It is the only remaining wonder of the original 7 wonders of the ancient world. Yet, it is not alone. Over 100 pyramids, large and small, dot the landscape along the Nile. The first step in pyramid construction was quarrying the stone. For the bulk of the pyramid, blocks of soft, locally sourced limestone were the primary material. Harder, denser limestone formed the casing, while the inner chambers and passages often featured granite, quarried from Aswan, nearly 500 miles upriver. The question of how such massive stones were cut speaks to the heart of ancient Egyptian technology. Archaeological evidence points to the use of copper and bronze tools, chisels, saws, and drills. While bronze is softer than the limestone and granite being worked, the Egyptians compensated with ingenuity. Copper saw blades, for instance, were used with sand as an abrasive, the sand particles doing the actual cutting as the saw was drawn back and forth. When working granite, which is significantly harder, tubular copper drills and dolerite hammerstones, themselves harder than granite, were used to pummel and shape the rock. Experimental archaeology has demonstrated that, with sufficient time and a coordinated workforce, these methods are indeed effective. Chisel marks and unfinished blocks at various quarry sites show the characteristic parallel grooves left by these ancient tools. But cutting the stone was only the beginning. Once quarried and shaped, the stones had to be transported, sometimes only a short distance, sometimes all the way from Aswan, down the Nile to Giza. How did the Egyptians move such enormous weights without the benefit of wheels, cranes, or modern vehicles? The answer lies in a combination of brute force, clever engineering, and the natural properties of their environment. The Nile itself was the lifeblood of ancient Egypt, and its annual inundation provided both fertile soil and a natural highway. Historical records and depictions in tomb paintings reveal that the Egyptians used large wooden sledges to haul stones overland, lubricating the sand in front of the runners with water. This simple technique reduced friction, making it possible for teams of workers to drag stones weighing several tons. For longer journeys, stones were loaded onto barges and floated downstream during the annual flood, when the river was at its highest and could accommodate heavy cargo. At the Giza Plateau, the final leg of the journey began. Here, the stones were hauled up from the riverbank to the construction site, often ascending ramps built of mud brick and limestone chippings. Archaeologists have discovered remnants of these ramps, some straight, some zigzagging, others spiraling around the pyramid's base. The specifics of ramp construction remain debated, but most agree that ramps were crucial for raising stones to the higher levels of the pyramid. Some hypotheses suggest external straight or zigzagging ramps, while others propose internal spiral ramps built into the body of the pyramid itself. Once the stones reached their destination, the challenge shifted to precision, fitting each block so tightly that the joints are almost invisible. This level of craftsmanship is perhaps the most astonishing aspect of pyramid construction. Here, the Egyptians' mastery of measurement and survey comes to the fore. They used simple yet effective tools, plumb bobs for vertical alignment, leveling instruments using water, knotted ropes for measuring distances, and set squares for right angles. The ancient Egyptian cubit, a standard unit of length based on the forearm, enabled consistent measurement across the workforce. Teams of skilled stonemasons worked meticulously, shaping blocks to match templates and checking alignment at each step. The pyramid's orientation, almost perfectly aligned to the four cardinal points, reflects a sophisticated understanding of astronomy. The builders likely used the stars, particularly the circumpolar stars, as guides. By observing the transit of these stars and marking their passage with sighting rods or cords, the Egyptians could establish true north with remarkable accuracy. As the pyramid rose, work became ever more complex. The workforce, estimated by modern Egyptologists to number between 20,000 and 30,000 at peak construction, included not only laborers but also skilled artisans, engineers, surveyors, and overseers. Contrary to popular myth, these were not slaves in chains, but a well-fed, organized workforce, supported by a sophisticated logistical operation providing food, water, tools, and shelter. Archaeological digs at workers' villages near Giza have uncovered bakeries, breweries, and medical facilities, painting a picture of a workforce motivated by pride, religious duty, and the prospect of social advancement. Despite our growing understanding, debate continues about the finer details. Some suggest that the Egyptians used counterweights or levers to lift stones, or even employed cranes of a sort, fashioned from wood and rope. Others propose more speculative hypotheses, such as the use of concrete-like materials or lost technologies now forgotten. Yet, the bulk of evidence points to a combination of simple tools, clever engineering, and the mobilization of a vast, skilled workforce. The fitting of the stones themselves was an art form. Each block was shaped and dressed by teams of masons, who used pounding stones to roughly shape the block, chisels and abrasives to refine the surfaces, and copper saws or drills for fine work. The final fitting required repeated lifting, shifting, and checking, an iterative process in which masons would move a block into place, mark points of contact, remove the block, and shave away high spots until the fit was perfect. The casing stones, in particular, were polished to a high sheen, creating a brilliant white surface that reflected the sun, making the pyramids visible from miles away. Inside the pyramid, the construction of chambers and passageways presented its own set of challenges. The Grand Gallery, King's Chamber, and mysterious air shafts required precise engineering to ensure stability. The use of massive granite beams to form relieving chambers above the King's Chamber distributed the immense weight of stone above, preventing collapse. These architectural solutions, combined with the careful planning of passageways and ventilation, demonstrate an advanced understanding of structural forces. The question of lost technology is an alluring one, often fueled by the sheer scale and precision of the pyramids. Some fringe theories suggest the use of advanced machines, anti-gravity devices, or even extraterrestrial assistance. However, there is no archaeological evidence to support these notions. Instead, the cumulative record, tools, unfinished stones, quarry marks, worker settlements, points to methods that, while labor-intensive, are entirely within the capabilities of a determined Bronze Age society. One clue to the Egyptians' mindset lies in their concept of ma'at, order, balance, and harmony. The construction of the pyramid was not merely a technical challenge, but a sacred act, aligning the pharaoh with the cosmos and ensuring the perpetuity of the state. Every stage of construction was imbued with religious significance, motivating the workforce and inspiring them to achieve feats that would echo through the ages. Recent discoveries continue to shed light on pyramid construction. In 2013, archaeologists uncovered a papyrus diary written by Merer, an official involved in transporting limestone blocks from Tura to Giza. His detailed accounts describe the use of boats and canals, confirming long-held theories about river transport. Other finds, such as ancient ramps at the Hatnub quarries, illustrate the use of sledges and inclined planes to move heavy stones. As the last casing stones were set in place and the capstone, or pyramidion, was positioned at the summit, the pyramid would gleam in the sunlight, a beacon to the living and the dead. Over the centuries, the casing stones were stripped away for other building projects, and the pyramids weathered the elements, but their core remains, silent witnesses to the skill and vision of their builders. To appreciate the pyramid builders' achievement, it is instructive to consider modern attempts to replicate their work. Experimental archaeology projects have built small-scale pyramids using only tools and techniques available to the ancient Egyptians. These efforts, while challenging, have demonstrated that, with sufficient organization, manpower, and time, the construction of a pyramid is not only possible but achievable using Bronze Age technology. The legacy of pyramid building did not end with Giza. Later pyramids, such as those at Saqqara, Dashur, and Meidum, reflect an evolution of technique and design, from the early step pyramids to the smooth-sided masterpieces. Each project built on the lessons of its predecessors, as engineers experimented with new angles, construction methods, and internal layouts. In the end, the mystery of the pyramids is not that they were built, but how the builders overcame each challenge with creativity and resolve. From quarrying and transporting stone to precise measurement and alignment, from logistical organization to spiritual motivation, the ancient Egyptians marshaled all the resources at their disposal to create monuments that would endure for millennia. The story of pyramid building is, at its heart, a story of human achievement. It is a reminder that, even in an age before modern machines, people could accomplish the extraordinary through cooperation, ingenuity, and the relentless pursuit of a shared vision. The pyramids stand as silent testimony to what is possible when a society dares to dream on a grand scale and has the will to turn those dreams into stone. While questions remain about the details of ramp construction, the precise methods of stone fitting, or the daily lives of the workers, each new discovery brings us closer to the truth. The pyramids, in their immensity and precision, continue to inspire awe and curiosity, inviting each generation to marvel at their grandeur and to seek answers to the ancient question: how did they do it? The answer, as we now understand, is found not in lost technologies or supernatural powers, but in the power of human ingenuity, an ingenuity that, stone by stone, lifted dreams into the sky and left a legacy for all time.